Hi, welcome to MST classes. Now let us discuss about prove that root 2 is irrational. Let us prove this by using contradiction method. Assume contrary to the root 2 is irrational, that is root 2 is rational. If it is rational, then there must exist two integers r and s such that s should not be equal to 0, and it can be written as root 2 can be written as r by s. Suppose r and s have a common factor other than 1. Then we divide by the common factor. Then we get at last as a by b form, simplest rational form. The root 2 can be written as a by b simplest rational form, where a and b are co-primes. Now, so when you cross multiply this b to the left side, then it becomes b root 2 is equals to a. B root 2 is equals to a. If we square on both sides, squaring on both sides, then we get b root 2 whole square is equals to a square. Then b square into 2 is equals to a square. Now you can say that b square is written as a square by 2. 2 you take to the right side, then it will become b square is equals to a square by 2. Statement 1 states that if 2 divides a square, 2 also divides a, isn't it? Statement 1, according to statement 1, we say that if 2 divides a square, then 2 also divides a. Therefore, we can write a as 2 into c for some integers c, because here 2 divides a square, means a square can be written as 2 into b square something. So a is written as a also can be written as 2 into c. 2 a is equals to 2c. Now substitute this a is equals to 2c in equation 1. In place of a square, you write it as 2c whole square. Then we get 2b square is equals to 2c whole square is 4 into c square, 4c square. Therefore b square is equals to 4c square by 2. When divide with 2, 2 2s are 4. So here only 2 into c square. It remains as 2 into c square. So now this means that 2 divides b square, and according to statement 1, what is statement 1? If 2 divides a square, 2 also divides a. So here if 2 divides b square, so 2 divides b2. Again using statement 1, we say that if p is equals to 2, 2 divides b square, then 2 also divides b, right? Therefore, but this is this means that both a and b have 2 as common factor. So is it possible? Because a and b should be co-primes, there should not be any common factor. But here a and b have 2 as common factor. So but this is a contradiction to the fact that a and b are co-primes and have no common factors other than 1. So this contradiction has arisen because of our assumption that root 2 is rational. So we conclude that root 2 is irrational. In general, it can be shown that root d is irrational whenever d is a positive integer which is an imperfect square, like root 2, root 3, root 6, root 8, root 24, etc. These all are irrational numbers only. Thank you.